Hi, I'm Erkin and this is Jan, and today we're going to talk about our machine learning project we did for our machine learning class.
The aim of this project was to reach maximum possible accuracy with traffic sign recognition of autonomous vehicles, and in this project we reached an accuracy of 98%, which is so awesome.
In autonomous vehicles, standard computer vision techniques were utilized to detect and classify traffic signs, which really require a considerable amount of time to design and detect the important features in images.
Instead, we created a convolutional neural network using deep learning techniques to do this multi-class classification task for us. For this purpose, we found a dataset from German traffic sign benchmark and used Python 3.5, TensorFlow, and other modules to complete this project.
We collected over 51,000 images and we split them into training, validation, and testing datasets. And each image is an RGB image with the dimension of 33 by 33.
We started the data pre-processing step by first converting the images into grayscale because it decreased our training time parameters and reduced any potential noise. Also, we applied standard normalization on grayscale images, which made our dataset more uniformly distributed.
For the model construction, we built up a deep neural network called SOLINET, which is a modification of Jan LeCun's model. Our model is composed of 3 convolutional and 3 fully connected layers, and we use a 3x3 kernel to filter our images.
So we ran the training process 6 times with different dataset and other models parameters on our Google Cloud Platform instance. For the first run, we used our fully colored normalized dataset and achieved an accuracy of 92% on both validation and test dataset. However, the loss values of the validation set pointed out that there was an overfitting problem.
So then we decided to use dropout technique, which Geoffrey Hinton introduced in his paper and suggested to use when there's overfitting. We used the same dropout value for both the convolutional and fully connected layers. Initially, we applied a 25% dropout to see if we will be able to abstain from the overfitting problem. For the colored dataset with 25% dropout, we achieved a validation accuracy of 98.5 and testing accuracy of 97%. And the loss values for the validation dataset also revealed that the overfitting problem was resolved.
We then decided to check whether a dropout of 50% would give us a higher accuracy. However, 50% dropout gave a lower accuracy of 97.1 for the validation, whereas 96 for the testing dataset. Therefore, we concluded that our best option for our color dataset is normalized and with a 25% dropout for both the convolutional and the fully connected layer.
In the next part of our project, we decided to try and see how grayscale images performed compared to color ones. Similar to what we did with the colored models, we first tried our model on normalized grayscale dataset without dropout, and not surprisingly, our model experienced an overfitting problem and produced a validation accuracy of 92% and a test accuracy of 93%. So just like what we did for the colored dataset, we applied a 25% dropout.
This time we obtained a validation accuracy of 98.6% and a test accuracy of 97.3%. The overfitting problem was definitely solved. Finally, we decided to try 50% dropout to see whether the accuracy was going to increase or not. In fact, we obtained a higher validation accuracy of 98.8%. However, our test accuracy was less compared to 25% dropout with only 96.4%. Therefore, we concluded that our grayscale normalized images with a 25% dropout in the model outperformed others, including colored ones.
So our final part of the project was to test our trained model with new images as well and to see how it performed.
So as a conclusion, in this project, we coupled the machine learning skills we learned in class with deep learning skills to perform traffic sign classification. We employ different pre-processing and regularization techniques such as dropout and reach a 98% accuracy with our model.
So overall, it was very enjoyable to gain experience in TensorFlow along with the other libraries we used extensively in our machine learning class. This project really reinforced our knowledge in machine learning as well as our intuition about deep learning.
So we hope you enjoyed this video. If you find this video interesting, please give us a like and take ECS 475 next year.